So I just wanted last year when I was on this forum, we were uh, in the HyperProtect organization. We were focused on the cloud technologies with HyperProtect as our area of expertise, and since 2024, we have done a pivot uh, to service the IBM LinuxONE platform with again HyperProtect as our mainstay. And with the pivot, we are bringing all our learnings from what we learned on the cloud platform and bring them over to the LinuxONE on-premise scenarios. The solutions that we developed earlier, we have been able to repurpose them for the on-premise environment, and still keeping some of the learnings that we had in terms of customer interactions, what were the use cases, and translate them over to this larger context of the Linux One. And that's what I wanted to cover in this presentation here today. So the agenda for today's meeting is, we already done with the introduction, so I'll jump right into confidential computing, and we have a demo that we'll play in a little bit after I cover a few slides. We'll talk about encryption management for the enterprise with what we call as enterprise encryption platform that will be available on on-premise Linux One very soon, and basically cover other solutions built on the Linux One platform with HyperProtect as the platform of choice. And let's go ahead and talk about why HyperProtect in the first place. It's all because we want to protect crown jewel data. And when we talk about crown jewel data, it could be personally identifiable information, also called as PII, personal health information, corporate financial data. It could be national secrets as well, and critical research data that is very important to be uh, kept in safe repositories and protect from unauthorized access and all that. And when it comes to protecting, we have three states of data that we know of. When traveling over the wire, it's in motion. While it's on disk, it's at rest. And while being processed, it's in use. And the fourth state is, I would say, quantum safe capabilities will also be covered here in this presentation. Because with the explosion of quantum computing capabilities, all the encryption that we have today might become vulnerable pretty soon, and we can protect data today to protect from um, the havoc that quantum computing will cause later on, probably in the next 10 to 15 years. So I'll be touching a little bit on quantum safe as well in this presentation. So when it comes to crown jewel data today, you can find it on the internet. It could be in various states out there, critical infrastructure that needs to be protected, control systems like SCADA, control systems which protect our electric grids. It could be oil pipelines. There are blockchain applications where you have digital coins, wallets, and all kinds of things. And HyperProtect has a special focus on the digital assets platform that we'll be talking about. Digital signature laws in terms of how do you sign packages, documents, and how to keep them safe from unauthorized access. Financial systems like transactions going through the banking system of today and the near future, enterprise applications as a whole, all of these and some more can have all the crown jewel data that is very critical to organizations. What is crown jewel data for me could define my reputation, my company's stock price, for that matter. So all that needs to be taken into consideration when we talk about crown jewel data and how do we protect it from unauthorized access. We have seen several news articles about like the solar winds attack, for example, happened about 2 years ago. It's still in the news. Even today, I was hearing the news here where people from Microsoft were called over to the United States Congress to explain why things were not done properly and why things were not protected from attacks like the pipeline attack that happened with SolarWinds. There were other cases where a 21-year-old a national security guy. He was able to dump national secrets and then boasted about it on Reddit. So these kind of scenarios are kind of embarrassing, but it gives us an insight into what we can do to protect data and how we should be protecting data at all costs, at all times. So when you talk about protecting data at rest, it's basically you want to encrypt data wherever it is in whichever application. It could be in OpenShift clusters, it could be in databases, it could be in load balancers or Kubernetes clusters, VMware, storage subsystems. All these things need some kind of encryption capabilities, and we are talking about encryption services being provided with encryption key orchestration as the primary function for these encryption services to protect all the systems that comprise the whole enterprise. When you're talking um, about the reputation of the enterprise itself, everything needs to be protected. So that's the data at rest. When we talk about data in use, this is kind of a difficult concept to convey, and this is where I was thinking about uh, how do we explain confidential computing, and this is what I came up with. There is something called as a SCIF, Sensitive Compartmented Information Facility. And this is basically used by national security agencies and other top secret organizations to, it's like a container room. It's like a 18-foot container that you normally see. It's corrugated steel and all that. And once you go inside the container, you are basically cut off from communications from outside world. Your cell phones don't work inside. You are supposed to open all your top secret documents and everything inside this compartment and not outside by design. So it's like a secure room or compartment to handle sensitive information and to prevent data leaks and to keep unauthorized users out. So this analogy is what we'll use when we talk about confidential computing when we in the latest parts of this presentation. When it comes to quantum computers of the future, encryption of today, for example, DES or other encryptions which have been marked as not safe when it comes to quantum computer capabilities, you have to make sure that you protect data today so that harvest now, pay off later kind of attacks can be prevented. So basically, you identify what's your crown jewel data to protect and take it through quantum safe encryption services and protect them in repositories which are also quantum safe repositories. So this is just a simple introduction of what the whole process will involve, and then we'll go into some details about the use cases and all that. So when it and this APAC conference is all about IBM Z, the LinuxONE. So question is why LinuxONE, what is LinuxONE and all that. So when we talk about LinuxONE, it's all about world-class cryptography. We have quantum safe capabilities available on the platform. We have the industry's highest rated tamper-proof cryptography facility here. Hardware support for symmetric algorithms like DES, triple DES, AES, and all that. And each crypto card on the LinuxONE, it's also called as Crypto Express card, can support hundreds of cryptographic domains. That is itself enough for the whole enterprise to serve all the encryption requirements for the whole enterprise. And when you talk about a complete AI platform, the LinuxONE also has the industry's first on-chip AI accelerator. So you can run your AI applications that much faster when you run on the LinuxONE compared to any other platform. It comes in multiple form factors. The smallest one could be a rack mountable one, which is just 64 gigabyte RAM and grow up to 16 terabytes of RAM. And there could be several other combinations in between. It supports all the open ecosystem, and HyperProtect for workloads is what my area of interest is from the HyperProtect organization. So we can protect data in memory with confidential computing, protect data on disk databases with encryption, and much more. So why LinuxONE is because it supports major middleware that forms the basis or the core of all the applications that are running in the industry today. You talk about WebSphere, DB2, Kafka, Postgres, everything that's listed here, and this is not an exhaustive list by any means. So it supports all the platforms that are used in the industry today for enterprise workloads, and it's as open as it can be. You see all the logos here. We don't have to list out everything. You can probably find something that you work with on a daily basis, and all of that is supported on LinuxONE, and much more is coming up. There is a repository where you can go and download containers for the S390X LinuxONE platform and run with that. So going further, um, when it comes to the LinuxONE, the core capabilities are the CryptoExpress cards with the HSM, which is at the highest level, FIPS 140-2 level 4. We have secure execution on the platform, the AI unit, and the CP assist for cryptography, and many more things on the LinuxONE platform. But what we'll be concentrating on from the HyperProtect perspective is using the CryptoExpress cards uh, to to provide world-class cryptographic encryption capabilities for the enterprise as a whole, and leveraging the secure execution for Linux to prevent workload data from being inspected, mitigation of security threats, etc. And then we can also leverage the AIU to accelerate our AI workloads on the LinuxONE platform. So when it comes to hyperprotect services and leveraging the features of LinuxONE, as we talked about the confidential computing enclave like a SCIF, we can run the confidential AI stuff on the AI toolkit, which runs inside a hyperprotect virtual server and leverages the AIU. So this is a very high level view of what all is possible with hyperprotect services. And as we go along into the use cases, things will start becoming clearer as we go along. Any questions up until now?
No questions up until now, Sandeep.
Okay, thank you, Ben. So as mentioned, there are 3 core services at this point, and the fourth one is coming up from the HyperProtect stable. One is confidential computing, and the service is called HyperProtect Virtual Servers. It's available on-premise on the LinuxONE, and if you want to do a quick POC, you can also do that on IBM Cloud today. And then, I mean, that's what I propose to most of my customers as well, like do a quick POC on the cloud and then move lift and shift over to an on-premise for the best experience possible on the LinuxONE. And from the cryptographic services perspective, uh, most of you might be knowing HyperProtect crypto services on IBM Cloud, and a similar service is will be available on the LinuxONE on-premise. Digital airlock services, this is for LinuxONE on-premise at this point. It provides secure airlock for cold storage, and we have some use cases that we can talk about it on where this will be useful. It basically provides you an auditable mechanism to manage communications between the inside and the outside world, and what happens behind the firewall inside your enterprise data centers and all that. So when it comes to confidential computing with LinuxONE, this is a very basic example of why it is necessary. First of all, if you see here, there are 2 sections of this chart here with confidential computing and without confidential computing. It's a simple application where you make a payment on a website or a mobile phone or something. And what happens without confidential computing is you are able to dump the memory and see how the all the PII information that is visible in the dump. But when it comes to confidential computing, everything is kind of a uh, garbage when you try to dump the memory. So here I would stop sharing and have Nancy play a little video which goes through the app itself and what confidential computing actually means.
Confidential computing is the protection of data in use through a hardware-based technique. In this video, we will demonstrate how to protect personal identifiable information and credit card information entered into web forms using confidential computing on the HyperProtect virtual server. HyperProtect virtual servers can be provisioned in IBM Cloud Virtual Private Cloud and is available as an on-premise offering as well. The HyperProtect platform provides technical assurance as opposed to operational assurance provided by other cloud providers. What this means is that the cloud operator cannot access customer data. IBM Cloud HyperProtect virtual servers takes advantage of IBM Secure Execution for Linux to provide an impenetrable boundary around workloads to protect from internal and external threats, implement zero trust principles by using multi-party contract and attestation, of which application binaries get deployed, and protect against malware by using secure build processes. To demonstrate technical assurance of the HyperProtect virtual server platform, we will run a simple Pay Now application that will accept PII and credit card information from a web form. We will run the Pay Now application on two servers side by side. One without confidential computing, where a malicious root user can dump contents of the server memory that is not protected to steal PII and credit card data. One with confidential computing, where even the root user can't access the server memory, as memory is protected by the HyperProtect platform. To be able to demonstrate the features of confidential computing, we will need a cloud SRE to access the LinuxONE machine on which virtual servers are provisioned. Since we are not able to assume the SRE role, we will instead create two virtual servers on the LinuxONE server in our lab environment, where we have root access. You can also achieve this level of confidentiality on the cloud with HyperProtect Virtual Server for vPC. Let's first bring up the Pay Now application on the server without confidential computing. Log on to the virtual server and issue the docker compose up command. Now, let's navigate to the Pay Now website and make a payment. Let's go back to the server side and check if we can see the PII information in the server memory. Find the process and dump the memory for the process. Search for the name string in the memory dump. You can see, without confidential computing, it is possible to collect PII data and other sensitive data in use from memory. Now, let's see how we can protect data with confidential computing. To do so, we have to first create the contract to define the workload that is going to run on the server. To create a contract, we need to bundle the required Docker containers into a Docker Compose file. The contract is used to identify the workload that is going to run on the Pay Now application, the logging server that the application server will connect to, and any other authorizations required for the server. Once the HyperProtect virtual server is created with a contract, the parameters of the contract cannot be changed. We will bring up the Pay Now application on the server with confidential computing with the contract. Now, let's navigate to the Pay Now website on the server with confidential computing and make a payment. Finally, check if the PII information is exposed this time on the server. As you can see, nothing is found because confidential computing protects your PII and sensitive data in use through memory encryption. You can also achieve this level of data security on the cloud. To provision a HyperProtect virtual server for VPC with confidential computing on IBM Cloud, take the following steps. Navigate to virtual server instances on IBM Cloud Catalog. Toggle the confidential computing switch. Name the virtual server instance. Copy and paste the contract to the user data field under Advanced Options. Click Create Virtual Server to create the instance. Thanks to HyperProtect virtual servers, you can now rest assured that you have a level of data security that is unmatched in the industry. To learn more about the portfolio of HyperProtect services, please visit our homepages.
So hopefully that gave you a little perspective on what confidential computing actually means and what are the capabilities in a very simple way that we are trying to explain there of why confidential computing is required. Now we can go through some of the other use cases, and I'll breeze through some of these slides here, so that we can have some time at the end of the session for some Q&A. So this is a simple digital wallet use case where the wallet application that is accessed by the clients needs to be protected, and we have to make sure that the application is running the code that's intended to be, and it goes through what we call as a secure build server process, the pipeline and all that. There are several components of this pipeline here, how the GitHub application is built using the secure build server. It's put in the container registry, and how the contract is created. So we are building a demo as we speak. My team, the Z client acceleration team, is building a demo that can be used to showcase to your customers if you want to use that later on. So we'll have some more updates on this one very soon. Confidential computing for healthcare scenarios, for example, where you have PHI information, the personal health information that needs to be protected. So you basically, at the front end, you separate PHI and non-PHI information and put it in and process all the PHI in an HPVS container, so that all the PHI is protected from unauthorized access. And we have tested out the scenarios for some of the use cases that we have worked with in the healthcare, and also for one of the defense industry use cases that we worked on. I see one of the participants of the POC is on the call here from IBM Japan team. So if there are any questions on what we did for the defense industry application, we can talk about that offline. When it comes to digital assets, protecting file-based digital assets, for example, one of our customers uses file-based digital assets, and they wanted to protect it using quantum safe algorithms using the Edwards curve signing services. So we provided the solution, and they went ahead and published a blog on the solution that was provided. I mean, the comment that we got back was, this service is at least 20 times faster from the quantum safe perspective, or from the signing services perspective, when compared to similar services available on other hyperscalers and I don't like when they were doing comparison with other hyperscalers who provide similar services. When it comes to tokenization solutions, uh, we are using uh, like we are running POCs on the tokenizer itself right now. You can use a simple tokenizer inside of an HPVS, which could be as simple as a UUID generator, which tokenizes information like social security numbers and then stores that in databases so that only tokenized values can be used for application processing. And we leverage the AIU on the Linux one to run inferencing. So this is another POC that is coming along, and we'll have a demo pretty soon on that one. When it comes to digital assets, protecting digital assets, offline signing orchestrator is a service that can be used to provide the digital air gap um, from uh, and at the same time allow interaction with outside entities, uh, but at, but making sure that every interaction that happens from the outside to the inside is audited and controlled by airlock reviewers and admins, so that the applications in the backend can be protected, cold storage can be protected, and stuff like that. I don't want to go into a whole lot of detail with all this use cases here, because these could be very specific use cases that may or may not be applicable to your scenarios. But if you want to go deeper into any of these, feel free to reach out to me or to anyone on the Zcat team, and we'll be able to help you put together these solutions, because we have tried and tested these in our environment, and we can do the same for your customer situation as the case may be. Uh, like for example, signing service on the Linux one. If you are a developer in IBM, you probably sign your code before it publishes, and IBM's own CIO, the code signing service, is built on the LinuxONE HyperProtect crypto services. So they were using a different HSM and different services before December of 2022, and we were able to transition them over to HyperProtect crypto services, and similar things can be done on IBM LinuxONE on-premise as well. We talked about file-based digital assets, and when it comes to encryption services, this picture that you see is a very simple Linux server. And how do you protect data at rest on a Linux server that is attached to the Linux server? Basically, you use in Linux environment the Lux passphrase, and uh, if you wrap the Lux passphrase with an encryption key, now you have a very powerful tool in your hand where you can protect the Lux passphrase in thousands of Linux servers like this using a key coming from an HSM. This could be HPCS in IBM Cloud, HyperProtect Crypto Service in IBM Cloud, or this could be an on-premise encryption provider like enterprise encryption platform that's coming up soon. But this can be done right now without all the fanfare, but with all the capabilities that you need to protect your Linux environments. And you could have thousands of Linux servers and millions of Linux servers around the world. One of our banking clients has implemented this one right now, and we have enhanced the solution by kind of providing capabilities that will disable Linux servers as and when required when a breach is kind of found out. So very powerful capability. It's available as open source right now, and you can try it out. There is a developer article that was written with all the detailed steps on how you want to implement this one. You can see at the bottom of this slide here. When it comes to protecting databases, the database could be running on the Linux one, and then you can do HSM integration using PKCS11. We have tried and tested with DB2, all the flavors of Postgres, FAP, EDP, Oracle, TDE, transmit data encryption. Your databases could be running anywhere in other clouds as well, and you can simply integrate with the HSM on the Linux one using PKCS 11 capabilities. So all these use cases that are being shown here have been tried and tested. So if you have any questions on how to implement, feel free to reach out. Uh, Now, what you see here is basically bringing all the platforms together, and all of them can be using the HSM capabilities of the Linux one. So what you see here is the storage subsystems. Um, for example, the spectrum scale was protected for one of our clients and in the fab area, like Cadence Design Systems. There was a big blog that was published. Cadence Design Systems is actually building fabs here in the US, and those fabs need to be protected. Data that the customers bring to the platform needs to be protected. So all of that is now being protected using the HSM capabilities of the Linux one. And it's happening as we speak today. So we can do the same thing with AIX as also. Anything running on AIX, it can talk directly to the encryption services on x86 platform. If you have Mongo DB or EDB, which is a Postgres flavor, you can do the same thing using either API services or PKCS 11 services by talking directly to the HSM. And similarly, you can protect volumes on AIX using the previous capability that I talked about. This one here, where you protect the LexPass phrase. You can do the same thing on AIX right now. And one of our banking clients is using this one as we speak. When we bring everything together, one of my previous very initial slides was encryption services for the whole enterprise. So this is what I call as something that will be useful for the whole enterprise. You don't need to have piecemeal solutions. You can use the encryption capabilities of one Linux one to service the whole enterprise. Of course, you want to build high availability solutions, and that will take off some of the that will change the design a little bit on how you want to implement it. But suffice it to say that one one Linux one can service the whole enterprise, whether it could be running on Power AIX, Power AIX, or Windows, or other cloud platforms, storage subsystems, and everything can be brought together under the umbrella of the Linux One platform here. Um, we have seen this in the cloud context, where we have HPCS UKO right now running in IBM Cloud, and similar capabilities are going to be available on the enterprise encryption platform with Linux One on-premise, where you'll be able to manage your encryption keys and data in other cloud environments. So if you want to visualize what this means, this slide here can probably give you more information about it. For example, during the COVID pandemic, some of the banking customers uh, had to follow heightened regulations on how the data is being protected and when it is in the clouds like Azure or AWS or other cloud environments like GCP and all that. So the bank customers wanted to make sure that any encryption that is being used in Azure, for example, is protected, and they have complete control over all the encryption that is happening inside Azure from their control center perspective. So HPCS UKO currently in IBM Cloud, it can be configured in an on-premise scenario also. So the idea is to be able to create encryption keys on the Linux one and push them out into the key vaults of Azure or key vaults of AWS and use those keys. For example, you see this purple key here to kind of protect uh, the data that is being protected with this green key, for example. So the green key here is a combination of the purple key and the blue key. You must have seen in the news recently about some problems with BitLocker encryption in Azure. I think it was 2 or 3 days ago. And any BitLocker encryption is managed by Azure, by Microsoft. So if the bank wants to have complete control over what is happening to their data and their encryption, this makes much more sense because now they have a kind of a red button control in their hands. So if they disable this purple key here on the IBM side, either it could be on IBM Cloud or on-premise LinuxONE, this key inside the Azure key vault gets disabled. And so the green key, which is a combination of the purple and the blue key, will get disabled as well. And there is a demo video that we created that is available on Developer. There is a TechZone asset also available. So sellers can right now go to TechZone and provision an environment for themselves and try this out to see how that works. So the whole setup has been created as a TechZone asset for all of you guys to kind of try it out. This next slide is a similar one where we showcase how data in AWS can be protected. This is a simple example with S3 buckets, but you can use it for any applications, databases, or anything. So this particular box could be either a database or an application or wherever you want to use your encryption keys. So basically, same philosophy here. You create the encryption key here on the IBM side, on the LinuxONE or IBM Cloud, push that over to AWS Key Vault, and then use that for the encryption. So if anything happens, if there is a breach, you simply go and disable this key here, and everything in the S3 bucket becomes unusable instantaneously. So those are the kind of controls that we are looking for. Uh, I mean, hybrid cloud, multi-cloud, and all these different strategies that companies use these days, data flows from one place to another. It's important to make sure that wherever the data is, it's protected. Whether if it's in your firewall environment, you use data at rest protection. But when it's traveling out to other cloud environments, you want to make sure that data is protected there as well, and you have complete control over what's happening to the data, who has access to it, and all that. So and similar case with ODF clusters also. We have one customer, a major retailer in Canada, who was running in a satellite environment, IBM Cloud Satellite, and they were having applications with Cloud Pak for data, and they had ODF storage. And this was a solution that was provided to them where they could protect ODF storage in Azure using IBM Cloud HPCS services, UKO, Unified Key Orchestrator capabilities, and protecting data in Cloud Pak for data in an IBM Cloud satellite that was built in Azure. So imagine the possibilities here. This could be running anywhere, this OpenShift cluster, and how you can extend control over what you can, how your data can be protected when it travels out. Uh, I guess everybody on this call must be aware of the VMware HPCS integration capabilities that are available today. This is a well-known use case. Most of our financial services customers use use this capability today, and I guess KMIP protocol is used for vCenter to HPCS communication for obtaining the root key that is used as a KEK for protecting the data encryption keys used by the ESXi host here. Again, you can try this out, and if there are any questions, feel free to reach out. When it comes to enterprise crypto service integration, in an on-premise air-gapped environment, all this can be done on IBM Cloud. It can be done on-premise on the Linux one. So all the capabilities are transferable and transportable, and each of these items that you see here on the slide have been tried and tested, and uh, we have IP available on each one of these to try it out as required. Um, like some of the other slides are kind of miscellaneous, and we don't have to go through each one of them. This slide probably was one of the crowning glories for the Zika team, where we helped the retail industry tackle organized retail crime here in the US. And right now, I'm working with another banking consortium to kind of bring together banks on a common platform where they can use data from each participant, which could be on disparate sources of data, and using federated learning in a confidential computing environment to learn from each other's data without ever exposing the raw data. So there is a blog that was published on this particular capability, and the next generation of uh, like a collaboration platform that I'm working on today will be available very soon for sharing. That brings me to the end of my presentation.